Experimental study on behavior of steel fiber reinforced concrete with marble dust, done by M. Anand Kumar, A. Gunasekhar, R. Santosh, R. Sarath, and guided by Mrs. R. Nidya. Aim to study the properties of steel fiber reinforced concrete with marble dust and to compare its properties with the conventional Sfrc concrete. Objectives. The major objectives of this project are to increase the strength of the concrete, to resolve the environmental problems caused by large-scale depletion of natural resources, to reduce the dumping of waste materials, and to utilize them in concrete. Abstract. Marble as a building material, especially in palaces and monuments, has been in use for ages. Marble powder is obtained as a byproduct during the production of the marble stone. This marble powder can be used as a partial replacement for fine aggregate in concrete. This paper reports the experimental study undertaken to investigate the influence of partial replacement of sand with marble powder in steel fiber reinforced concrete. Marble powder was replaced in proportions of 20%, 30% and 40% for sand in Sfrc. The percentage of steel fibers used was 1.5%. The effect of marble powder is in properties of Sfrc was investigated. The investigations include the testing of compressive strength, tensile strength and flexural strength of hardened concrete. The concrete was tested on 7, 14 days and 28 days. It is found that the optimum percentage for the replacement of fine aggregate with marble powder is 30%. Literature review. The work by Mr. Nikhil A. Gaj, Professor S.S. Vidyal of Professor Ram on fiber reinforced concrete using slag and steel fiber concludes that the optimum dosage for partial replacement of cement by ground granulated blast furnace slag is 20%. The optimum dosage for addition of steel fiber is 1.5%. Experimental study on steel fiber reinforced concrete for M40 grade concludes that the compressive strength, split tensile strength and flexural strength are on higher side for 2% fibers as compared to the produced from 0%, 1% and 3% fibers. The compressive strength increases from 11 to 24% with addition of steel fibers. The flexural strength increases from 12 to 49% with addition of steel fibers. The split tensile strength increases from 3 to 41% with addition of steel fibers. To study the behavior of marble powder as supplementary cementation material in concrete, concludes that compressive strength increases with 30% replacement and also 45%, 50% replacement by sand. A journal on an experimental study of marble powder on the performance of concrete, the compressive strength of concrete increases up to 15% replacement of fine aggregate. The tensile strength of concrete for cylinder increases up to 15% replacement for fine aggregate. The flexural strength of beam increases up to 15% of replacement of fine aggregate when marble waste powder. Methodology. The methodology is as follows: material properties, mixed design, casting, testing, research and discussion, followed by conclusion.
Material properties. The properties of the materials used in our mix is shown. Cement. The grade of cement is OPC 53, specific gravity of 3.17, fineness 5% and initial setting time 27 minutes. Fine aggregate. Specific gravity of 2.53, fineness modulus 3.56 and it belongs to zone 2. Coarse aggregate. Coarse aggregate has specific gravity 2.86, water absorption 0.5%, impact value 10.53% and crushing value 15.76%.
A journal on an experimental study of marble powder on the performance of concrete, the compressive strength of concrete.
Marble powder. The marble powder used is of white color and it possesses specific gravity of 2.67. Application of marble powder. The various applications of marble powder are: it's used in power coating, paints and ceramic industry, leather, cloth and flooring application, detergent application, glass industry, etc. Mix design. We have done the mix design according to IS 10262 for M30 concrete and the maximum size of aggregate used is 20 mm. The target mean strength obtained is 38.25 Newton per mm square and the water cement ratio from the graph is 0.42. Calculation of water content and the cement content. The water content is found to be 186 kg for maximum size of aggregate 20 mm and the sand percentage of total aggregate is 30%. The cement content is calculated to be 443 kg per meter cube. The volume of fine aggregate was found to be 605 kg per meter cube and the coarse aggregate is 1145 kg per meter cube. The ratio was found to be 1:1.37:2.59 with a water cement ratio of 0.4. The specimens are casted for 7, 14 and 28 day testing of cubes. And the mixed proportions per meter cube is shown, and this for a cube specimen. For a single cube specimen the mixed proportions are shown. For a single cylinder specimen the mixed proportions are shown, and for a single beam specimen the mixed proportions are shown. Testing. The concrete were casted and cubed for 7, 14 and 28 days and the cube testing were done on 7, 14 and 28 days and the cylinder and the beam were tested for 28 days. Results and discussion. The compression strength of cube was found to be increased at 30% replacement of marble powder with fine aggregate. For 7 days it was increased at 31.56, and for 28 days we have got the strength as 42.22. It is the peak strength. It is a graph showing the compression strength of cube, and the maximum peak was found at 30%. Testing on cylinder and beam. Cylinder and beam were tested only for 28 days, and the maximum value was found at 30%. The maximum peak value is 3.44 Newton per mm square. This is the graph showing and the peak value. Flexural strength of beam, and flexural strength also increases at 30%, and the peak value is 3.82 Newton per mm square, and the graph showing the peak value.
Conclusion. As per 7, 14 and 28 day test results, the following conclusions were made. The partial replacement of fine aggregate by marble powder increases the strength of Sfrc concrete mix. The optimum replacement of fine aggregate by marble powder was found to be 30%. At 30% replacement, the compressive strength of concrete was found to be increased by 12% when compared to conventional steel fiber reinforced concrete. The split tensile strength was found to increase by 10%. The flexural strength was increased by 2%.
Cylinder. Thank you.